the biggest secret in the history of technology is that the world's most powerful systems often start from extremely small ideas. A simple observation, a strange experiment, or even a mistake can slowly grow into something that changes billions of lives. But what makes an idea powerful enough to reshape the future? Why do some inventions quietly disappear while others completely transform civilization? To understand this, we need to look at how ideas evolve. Every major innovation usually begins with curiosity. Humans notice a problem, a limitation, or something that simply does not make sense. Instead of ignoring it, someone decides to explore it deeper. This curiosity slowly turns into experimentation. Experiments lead to discoveries, and discoveries eventually become technologies. But here is the interesting part. The most revolutionary ideas rarely look impressive in the beginning. Take electricity as an example. When early scientists started studying electrical energy in the 18th century, most people believed it was just a strange scientific curiosity. They could create small sparks and static shocks, but nobody imagined that electricity would one day power entire cities. Yet curiosity kept pushing scientists forward. Experiments grew more advanced. Researchers began to understand how electrical current moves, how it can be generated, and how it can be controlled. Over time, those small sparks evolved into power grids, computers, the internet, and the entire digital world we live in today. The same pattern appears again and again in human history. The internet itself began as a small military research project. In the late 1960s, scientists were trying to create a communication system that could survive even if parts of it were destroyed. Their solution was to build a decentralized network where information could travel through many different paths. At first, the system connected only a few computers. It was slow, limited, and used mostly by researchers. But as computers became more common, this small network expanded. Universities connected to it. Then companies joined. Eventually, the system grew into the internet, the massive global network that now connects billions of devices every second. But innovation is not just about technology. It is also about perspective. Many breakthroughs happen when someone looks at a familiar problem from a completely different angle. Instead of asking, "How do we improve this?" they ask, "What if we rethink it entirely?" This mindset is what leads to disruptive innovation. For example, transportation was dominated by gasoline-powered cars for over a century. Improving engines and fuel efficiency seemed like the only direction forward. But some engineers asked a different question. What if cars didn't rely on gasoline at all? That question led to the modern electric vehicle revolution. Advances in battery technology and energy systems allowed electric cars to become practical. Today, electric vehicles are transforming the entire automotive industry. What makes this even more fascinating is that the technology behind electric cars had existed for decades. The real change happened when engineers combined existing ideas in new ways. This shows another important truth. Innovation often happens at the intersection of multiple fields. When computing power meets biology, we get genetic analysis and personalized medicine. When physics meets materials science, we get stronger alloys and new forms of energy storage. When artificial intelligence meets data science, we unlock machines that can learn patterns from massive datasets. These intersections create entirely new possibilities. Artificial intelligence is one of the clearest examples of this phenomenon. The concept of intelligent machines has existed for decades, but early computers were simply too weak to process the enormous amount of data required for learning algorithms. As computing power increased and data became more available, machine learning techniques suddenly became practical. Neural networks, systems inspired by the structure of the human brain, began solving problems that once seemed impossible for computers. They can now recognize images, translate languages, detect diseases in medical scans, and even generate realistic text, music, and artwork. What once sounded like science fiction is now a part of everyday life. But every technological leap also brings new challenges. As systems become more powerful, they raise questions about ethics, security, and responsibility. Who controls advanced technology? How should it be regulated? And how do we ensure it benefits society rather than harming it? These questions are becoming increasingly important in the age of automation and artificial intelligence. Throughout history, new technologies have always disrupted existing systems. When factories introduced machines during the Industrial Revolution, many workers feared losing their jobs. Similar concerns appear today with automation and AI. However, history also shows that technological revolutions often create new opportunities while eliminating old ones. Entire industries emerge around new inventions. New jobs appear that did not exist before. The key challenge is adaptation. Societies that adapt quickly to new technologies usually benefit the most. Education systems evolve. Businesses reinvent themselves. Governments develop new policies to guide innovation responsibly. This constant cycle of invention, disruption, and adaptation is what drives human progress. But there is another factor that determines whether an idea succeeds: timing. Sometimes an invention appears too early for the world to adopt it. The technology might be brilliant, but the surrounding infrastructure or culture is not ready yet. For instance, early tablet-style computers existed decades before modern tablets became popular. The idea was correct, but the hardware was too expensive, batteries were too weak, and internet connectivity was limited. Only when those supporting technologies improved did tablets become mainstream devices. Timing, therefore, can be just as important as the invention itself. Another fascinating aspect of innovation is how unpredictable it can be. Many discoveries happen by accident. Scientists searching for one solution suddenly notice something unexpected. Instead of ignoring it, they investigate further, and sometimes those accidents lead to revolutionary breakthroughs. Penicillin, the first true antibiotic, was discovered accidentally when a scientist noticed that bacteria stopped growing near a particular mold in his laboratory. That unexpected observation eventually led to a medical revolution that has saved millions of lives. This shows why curiosity and open-mindedness are essential in science and engineering. Progress rarely follows a straight path. It is messy, unpredictable, and filled with surprising turns. Yet despite this uncertainty, one pattern remains consistent. Human curiosity never stops pushing forward. Every generation builds on the knowledge of the previous one. Ideas evolve, technologies combine, and new possibilities emerge. The tools we use today would have seemed impossible just a century ago. And the technologies being developed right now may completely reshape the world in the next few decades. Quantum computing could solve problems that current computers cannot handle. Advanced biotechnology may allow scientists to treat diseases at the genetic level. Space exploration could open new frontiers beyond our planet. Each of these fields represents the next chapter in the story of innovation. But at its core, progress always begins the same way, with a question. Someone somewhere looks at the world and wonders how things could be different. They experiment, fail, learn, and try again. Slowly, their idea grows stronger, more refined, and more powerful. Eventually, what started as a small curiosity becomes a discovery. That discovery becomes a technology. And that technology changes the world.